Welcome to section 12.5. In this section we are going to be adding and subtracting rational expressions, and this is the first video. And in this video we're going to be adding and subtracting rational expressions with like denominators. So we're going to learn a couple of hints to get us going, and we will work ourselves through essentially our missing pages that we did. So in case we didn't get to this in your class, you should be able to fill out the missing pages for this. So first off, the inside of your addition side. So you have essentially your missing that looks something like this. You have two pages. We have multiplication, division, addition, and subtraction. Inside of this addition sign, you will have the following. So if this were the flap of your missing, and then this were the part attached to the book, so essentially you have your notebook page right there. On the flap, you're going to have a little bit that you're going to add to the top, little like maybe inch, and then we'll have some practice problems. And then on the other side, we're actually going to skip this for right now, and you're going to see this part in the next video, in video number 2, and that's where we're going to be looking at unlike denominators. So we're just focusing on the flappy part of your missing page for right now. Let's get going. So hopefully on your missing page, you have enough room to write in the top part this information. If adding rational expressions with like denominators, if you have A, B, and C, let A, B, and C are polynomials that aren't 0. If you had A plus B, or A over C plus B over C, you could write that as A plus B over C. So let's look at this little example right here. We have here 3b over b squared plus 5b over b squared. And as we can see, we have the same denominator, which is good. And so we essentially can transfer that denominator as 1 over to the other side and just write our top numbers, 3b plus 5b. Those two simplify, they add to be 8b. And we still have our b squared along the bottom, and from there we can simplify and we can get rid of a b from the top and the bottom, and we'll just simply have 8 over b for our final answer. If you notice, this is a lot like adding fractions with common denominators. Let's think of saying we are adding 1/8 plus 3/8. If we were to do that, we essentially just have our 8s that travel right on through, so the 8s continue through, and then we have 1 plus 3 on top. If we finish that up, we have 4 over 8, and then from there we can simplify. That's kind of like simplifying that b out. We can simplify this to 1 over 2, or 1/2. So this whole process is incredibly similar. Let's move on, and actually on the flappy part we're going to do a couple of practice problems. So we have x squared minus 8x divided by x minus 4 plus 2x plus 8 divided by x minus 4. So essentially, now let's zoom in and actually do this problem. We have a common denominator here of x minus 4. So what we can do is we can simply write x minus 4 down below. After that, we need to pay attention to everything up top. We have x squared minus 8x plus 2x plus 8. Last little bit that we need to do, or at least as of right now, or maybe not our last little bit, our first step that we need to do is combine like terms. So we need to identify what our like terms are. X squared isn't the same as anything else in here. We have a negative 8x and a positive 2x. Those are like terms, so those will go together. And we have an 8 on the end, and that doesn't belong with anything else in the numerator. So we can rewrite all this as saying x squared, negative 8x plus 2x is negative 6x, and add our 8 at the end, all over x minus 4. So essentially what we did just there was we combined like terms. Our next step will be to factor. So to factor x squared minus 6x plus 8, we will actually do a little, we can do bottoms up on this, or we could actually think about it and think guess and check. If we thought about the factors of 8, we have 1, 2, 4, and 8. So 2 and 4 are going to be the numbers we're working with because we have a negative 6 there. So we have x minus 2 times x minus 4. On the bottom, we still have our x minus 4, so you can see right away we have a common denominator. We have something that we can get rid of. We can simplify by x minus 4 on the top and the bottom. So our final answer will be simply x minus 2. Awesome. Let's go through and do one more problem like this. We have 2m plus 4 over m squared minus 9 plus 2 times n and 2 over m squared minus 9. Common denominator, as we can see, is this m squared minus 9. So we're going to have that there. And we need to just combine like terms. Like terms are the 4 and the 2. So we have 2m plus 6 on top. So we have essentially gone through our first step. We've combined like terms. Now we need to factor. We always need to factor before we simplify. Okay, so 2m plus 6, that can factor, we can factor out a GCF. A GCF for this is 2, so we can write 2 times m plus 3. And on the bottom, on the bottom, this m squared minus 9, that's a difference of squares. So as a difference of squares, we can write m minus 3 times m plus 3. That means there are like terms here. We can get rid, well, not like terms, there's similar factors. We have the same thing on the top and the bottom. We have an m plus 3 on the top, and we have an m plus 3 on the bottom. So our final answer for all of this is 2 over m minus 3 as our final answer. So let's move on, and we can actually start doing a little subtraction. So first of all, if you were to open your subtraction side of your foldable, so now we have a foldable, or our notebook looks like this. Here's our foldable. Here's the subtraction part. If we were to open up the subtraction part, we are going to be doing the flappy part first. Everything to the left of that, the base of the subtraction stuff is all right here, and that will be covered in the second video. So this is what we are covering right now. So you're going to have a little bit of writing up top, and then we are going to do 2 practice problems down below. So let's try to understand what's going on with subtraction. It's just like addition, except there's a subtraction sign. That's the only thing that's different. So essentially, if we have a, b, and c represent polynomials where c cannot equal 0, then we have a over c minus b over c. We can essentially just rewrite that as having one of the common denominators and a minus b up on top. So we can go through this fairly hairy little problem here. We have 3m minus 6 over m squared plus m minus 6 minus negative m plus 2 over m squared plus m minus 6. So up top, we're going to simply look at the 3m minus 6 minus the negative m squared. And what helps a lot is to think about this second set of information as being in parentheses. So we can, if we focus just on that upper stuff in the parentheses, we can essentially look at this negative as being sort of distributed into the other 2 terms that are inside of the parentheses, which can be really helpful when we're thinking about all of this. So essentially, that information, that 3m combines with the minus a negative 3m, which equals 4m, and then negative 6 minus 2 equals a negative 8. So we have negative 4m minus 8, which we can take a GCF of 4 out, and then solve for a more simple version of this equation, which is 4 over 3 plus, or m plus 3. So now from here, let's try a couple of practice problems and see if we can play around with this whole concept of subtraction with like denominators. On the left-hand side here, this is a problem that you should have in your missing by now, or that you should have in your missing now. We have 5a plus 2 over a squared minus 4 minus 2a minus 4 over a squared minus 4. So first things first, I suggest always putting these top binomials into parentheses, just simply because then we can see what is going to be subtracted later on, and it'll keep things sort of separated so we don't end up having small computation errors. So our common denominator as of right now is a squared minus 4. And on the top we have now 5a plus 2 minus 2a minus 4, continuing to keep things in parentheses. So you can go about this in one of two ways. You can either combine like terms and say 5a minus 2a, or you can say, okay, this negative is like a -1 and distributed in, and so you change all of the signs within the equation before you actually do any math. I actually tend to do things better just by saying, I'm going to be logical about it, take my like terms, 5a minus 2a, and doing that. So that is what I'm going to do. We're going to say 5a minus 2a is equal to 3a. As well, I'm also going to now look at 2 and the -4. So we have 2 minus a -4, that's like 2 plus a negative, or 2 plus 4, which is equal to plus 6. And all of this is over a squared minus 4. After that, we've essentially combined like terms. Now we need to factor, and factor could mean GCF. It could mean bottoms up. It could mean perfect square trinomials or difference of squares. And then after that we will simplify. So 3a plus 6, in here we have a common GCF of 3, so we can rewrite this as 3 times a plus 2. And on the bottom we have a squared minus 4, which if I think about this is a difference of squares. So I can rewrite this as a plus 2 times a minus 2. That's super helpful, super cool, because I see I have an a plus 2 on the top and an a plus 2 on the bottom. That means we can simplify that. And our final answer will be 3 over a minus 2. So that's how we do that with common denominators. Let's try one more problem and see how we do with this one. We have 2b plus 14 over b squared plus 3b minus 4 minus negative 2b plus 2 over b squared plus 3b minus 4. First things first, I'm going to add my parentheses to make sure I stay focused and organized. Now I'm going to rewrite this with one common denominator, so I have b squared plus 3b minus 4, and on the top we have 2b plus 14 minus a negative 2b plus 2. From there, I'm going to be very focused with my addition, with my subtraction, and I'm going to say like terms. I have a 2b and a 2b, and then I also have a 14 and a 2, so those are my like terms. If I do 2b minus a negative 2b, I have 2b plus 2b, which is 4b. As well, we have 14 minus 2, which is equal to 12, so we're going to add 12. We're putting this all over b squared plus 3b minus 4. After that, we need to factor. Our common factor, our GCF that I'm seeing between this 4b plus 12 is a 4. Woohoo, it stands out. So 4 times b plus 3 is how we're factoring that. Over bottoms up with this bottom equation, b squared plus 3b minus 4. We can turn this into b plus 4 times b minus 1. b plus 4 times b minus 1. Everything's completely factored. Everything's been done properly, and unfortunately, there's no common terms between the top and the bottom. So this, even though it's a big mess of an equation, is our final answer. Done. Practice a few problems. See how your homework goes. If you have any questions, as always, please email or call or text or whatever you need to do to get the information you need. I hope this helps. Be sure to watch a couple Khan Academy videos if you continue to have questions, and I will talk to you later. Bye.